The Earth and other worlds in the solar system are like a family in space. They were formed together some 4.5 billion years ago from the same round, flat cloud of gas and dust that created our sun. Now each world in the solar system is unique, but they all were formed by the same natural processes, and they all still move in an orderly way around each other and the sun. Some are primarily rock or ice. Others are great balls of gas, often encircled by rings. They all are illuminated by sunlight, and they reflect light back again, so that the closest and brightest of these faraway worlds look like stars in Earth's sky. Spacecraft from Earth have landed on only 3 worlds: the Moon, Venus, and Mars. But orbiting and close-passing spacecraft have seen more, and we're beginning to learn how the visions of dreamers compare to real places in our solar system. The system of worlds that we know best is double: our Earth and its large moon. Seen here from orbit by Skylab with the full moon in the distance, Earth is wrapped in a blanket of air that we can breathe. Earth is the only world we know where people can be outdoors without spacesuits. Earth is also the water planet, with oceans on 3/4 of its surface. If we orbited just a little bit farther from the sun, the oceans would be solid ice. A bit closer, and all water on Earth would have evaporated into space. Our world is located approximately 93 million miles from the sun, and it journeys once around the sun in 365 days, 6 hours, and 9 minutes. To complete an orbit in this amount of time, the Earth carries us through space at an average speed of 18 miles per second. The Earth and Moon were seen together in space for the first time in 1977, as NASA's Voyager spacecraft sped away toward the outer solar system. Compared to most other worlds and their moons, the Earth and its companion are nearly alike in size. Unlike the Earth, the Moon is barren, with no air and no liquid water. The side that faces us has broad, dark plains called maria, really ancient beds of lava. The Moon also has mountains and craters, mostly the result of impacts by gigantic rocks or asteroids, which flew loose in the solar system during its early history. People from Earth visited the surface of the Moon 6 times between 1969 and 1972. From NASA's Apollo missions, we learned many things. For example, that the Moon is more massive on the side that faces the Earth, that it may still be hot at its core, and that the Earth and Moon are made of the same stuff, only in different proportions. We also learned that people from Earth can venture to another world and return. 2 worlds, both without moons, lie inward from Earth in orbit around the sun. Seen here in ultraviolet light, Venus is a near twin to Earth in size and density. But this world is blanketed in thick clouds which trap the heat of the sun, so that it's hot enough on Venus to melt lead. Between 1978 and 1981, NASA's Pioneer Venus orbiter used radar to peer beneath the clouds to reveal that Venus is mostly flat. 2 highland regions, seen here artificially colored in yellow and green, have been named Ishtar and Aphrodite, in keeping with the practice of naming features on Venus for legendary goddesses and queens. Soviet Venera spacecraft have obtained glimpses from the surface of Venus, but no craft has survived for long on the surface, where the pressure is 100 times greater than surface pressure on Earth, and where temperatures range to 900 degrees Fahrenheit. Venus also has sulfuric acid rain, lightning, and possibly active volcanoes. Future spacecraft will explore there only with great difficulty. Mercury is the nearest known world to the sun. Slightly larger than Earth's moon, it's also scarred by ancient craters. Mercury rotates slowly beneath the nearby sun. Its day lasts for several of our months. Mercury's surface is porous, and it has no air. Temperatures on the day side climb to 450 degrees Fahrenheit, while on the night side they fall to minus 300, so that Mercury is simultaneously one of the hottest and coldest worlds in the solar system. In the other direction from Earth is Mars, the red planet, smaller and colder, but still tantalizingly similar to the Earth. NASA's 2 Viking spacecraft landed on Mars in 1976. They encountered a few relatively balmy days during the Martian summer, but frost in the winter when temperatures plunge well below minus 100 degrees Fahrenheit. Viking also saw clouds in a pink Martian sky. From orbit, Mars is seen to have a vast network of canyons that stretch halfway across the planet, a distance about equal to that from Los Angeles to New York. Mars is also a world of ancient volcanoes. Olympus Mons is the largest volcanic mountain on Mars, and probably in the solar system. It towers some 16 miles high, and its base covers an area larger than the state of Arkansas. There is water locked up in the polar ice caps of Mars, and a great deal more water is probably stored away underground in vast beds of permafrost. Pictures such as these are almost indistinguishable from similar river patterns on Earth. Many scientists interpret them to mean that water flowed on Mars in the distant past. Mars is the most likely next place for people to go beyond our own Earth and Moon. A manned mission to Mars has already been cited as one of NASA's long-term goals, and a few very long-range thinkers are already planning how the climate of Mars can be artificially warmed, the atmosphere reconstituted, and the planet made completely comfortable for human life. Orbiting Mars is Phobos, one of 2 tiny moons. Phobos and the other moon, Deimos, are believed to have been captured from the asteroid belt. They probably resemble the asteroids, which are almost countless chunks of material ranging in size from simple rocks up to objects the size of whole states, orbiting between Mars and the realm of the outer solar system. The first world in this outer realm, and by far the largest world in the solar system, is really central in its own system of worlds. Seen in detail for the first time in 1979 by the Voyager spacecraft, Jupiter is 1,000 times less massive than the Sun, but far more massive than all the other planets combined. The 2 Jovian moons seen here, Io and Europa, are each about the size of Earth's moon, while Jupiter itself is about 11 times Earth's diameter. When we look at this giant planet, we see only the uppermost layers of its atmosphere. Jupiter has a small core of melted rocky materials, but it is mostly composed of a vastly deep interior sea of liquid hydrogen helium, covered by an atmosphere of hydrogen and helium gas hundreds of miles thick. Jupiter's clouds are composed of tinted ammonia ice crystals. They are distant cousins to the clouds in Earth's atmosphere. The great red spot shown here is really a giant hurricane, larger than the Earth, which has raged without ceasing on the planet Jupiter for at least 4 centuries. Jupiter also has a thin ring, discovered by Voyager, composed of very small particles of dust. The planet Jupiter has at least 16 moons. The 4 large Galilean satellites were seen first by Galileo in the year 1610 as points of light through one of the first telescopes. Thanks to Voyager, we now know Io, Europa, Ganymede, and Callisto to be more like planets, each with its own surface and history. Io is the most famous of the Galilean satellites because this world is the only one besides Earth known for certain to have active volcanoes. This Voyager image shows an area on Io about 700 miles across. No craters can be seen because they've long since been blanketed by sulfurous material that constantly spews from Io's volcanoes. The volcano in the lower portion of the picture has been given the name Ra Patera for an ancient earthly god of fire. After Jupiter, Saturn is the next planet outward from the Sun, also the second largest world in the solar system. It was seen close up by the outbound Voyagers in 1981. Saturn's rings consist of individual particles of ice, from the size of pebbles to that of boulders, all moving like miniature moons in orbit around the planet Saturn. Voyager discovered that these rings are divided and subdivided, so that Saturn's rings actually number in the thousands. The rings show many peculiar features. The F ring, seen here, is clumpy and apparently braided in some places. The B ring displays these spoke-like features, which form, then are torn apart within hours as particles in the ring closer to Saturn orbit the planet faster. The spokes appear to be tiny grains that sometimes are levitated temporarily above the rings. Saturn has at least 17 moons, and probably more. The moons of Saturn are among the most exotic worlds in the solar system. The largest is Titan, seen here from behind. Titan's thick atmosphere appears as a ring in this picture, the result of scattered sunlight. The thick atmosphere of Titan hides its surface, which may have pools of liquid methane, and where conditions may be similar to those on Earth when it was young. Other moons of Saturn include Enceladus, with a surface that's nearly pure ice and that shows signs of recent change. Iapetus, with one hemisphere several times brighter than the other, and Mimas, which sustained an impact that must have nearly shattered this tiny world. Saturn, like Jupiter, also has a number of smaller moons. The moons shown here orbit at various distances from the planet. Some of the small moons of Saturn are called shepherding satellites. They're thought to help maintain the shape of the rings of Saturn. Other small moons are even co-orbital. That is, two or more moons share a single orbit around Saturn. The next planet out is Uranus, which spins on its axis sideways compared to the other planets. Uranus was the first planet discovered with a telescope, and it was the planet most recently seen close up by the Voyager spacecraft in January 1986. Voyager found a nearly featureless upper atmosphere for this outer planet. It also got the first good look at the rings of Uranus, which were discovered in 1977 by astronomers on Earth. It confirmed that the rings are thin and dark. They appear to be made of large boulders moving around the planet. Voyager also discovered 10 new Uranian moons, in addition to the 5 we already knew. The strangest Uranian moon is Miranda. Voyager passed only 19,000 miles from it. The spacecraft found at least one dark patch on Miranda that has the shape of a rectangle. No one knows what made these right-angle grooves. Voyager also saw this cliff on Miranda. It's several miles high. With no future missions to this world scheduled, these pictures of Uranus and its moons are the best we'll have for decades to come. Beyond Uranus, there are still more worlds, which spacecraft have not yet seen, but which are studied by Earth-based telescopes. Neptune is the fourth and final gas giant in the solar system. It has 2 known moons, Large Triton and Little Nereid, which mysteriously orbit Neptune in opposite directions, one clockwise and one counterclockwise. The Voyager spacecraft is due to visit Neptune in 1989. And finally, there is Pluto, whose very elliptical orbit has now carried it closer to the Sun than Neptune, where it will be until 1999. This icy world now may be developing a tenuous atmosphere, which will freeze and fall to the surface again when Pluto once more assumes the outpost position. In 1978, astronomers discovered Pluto's moon, which was named Charon. It has been seen only as an elongation in photographs of Pluto, but its presence challenges old assumptions about the outer solar system and makes us wonder how many other worlds in the Sun's family remain to be found. At McDonald Observatory and at other observatories around the world, astronomers use telescopes and sophisticated technology to scrutinize these neighboring worlds in our solar system. With telescopes and with future spacecraft, new worlds certainly will be found, and known worlds explored more fully. In the 1980s, the space shuttle will launch missions to Jupiter and Venus. It will also launch the Space Telescope, which will provide clear, sharp images of the worlds in our solar system and of what lies beyond. Children who are alive today will come to know these worlds. They'll even visit them, if not firsthand, then at least through the complex sensors of robot spacecraft. To discover and explore the surface of planet Earth took countless lives, over 20 generations and more. Now, for the first time in history, we have the chance to explore 20 worlds and more. Someday, these alien worlds of our solar system may seem less strange. In fact, to people of the future, they may seem a lot like home.